In the previous video, we modeled the components needed for the Machinist Jack assembly. Now, in this part 2 of the tutorial, we are going to create the final assembly. So create a new file. This time we go with the assembly. And this is our assembly workspace in SolidWorks. So when you come to this assembly tab, we have these commands that you can use to create the assembly. So since all the parts have been opened already, there is a pop-up window here that we can add the components from straightforward. So click on this base, which will be the first part you're going to add, and then you bring it here and click any area to release it. Change the background. Or we can just maintain this. So since you've placed the base, you have to position it very well so that the other assembly or the other components can just lock up to the base. So when you add the first component, it's fixed in the window. So when you try and move it, you can see the selected component is fixed. It cannot be moved. You have to make it float in the workspace. So right click and click on float, and then this time when you try and move it, you can see we move it in any way we want. Now after moving it, you have to fix it somewhere so that it will not be moving when you are assembling. So come to mate, and then you want to mate the origin of this part and the origin of the assembly workspace. So coincident mate under standard mate, and then click on this arrow here to drop down. We have the origin of the assembly workspace, and then drop down the base and then click on the origin of the base as well. After this, we want to align the axis of the base, so check this align axis. Okay. Now after we align axis, we can see this, the assembly is fully defined. This is what we want before we move on to the next part. So now insert components, click on the swivel, and let's check this is the right orientation of the swivel. So you can drop the swivel here alone, or if you want to drop the other components, hold the shift key and then click on the other components, select them all, drop the swivel here, and then for the bolt, this should be the orientation. So rotate it about the y-axis by clicking on this rotate about y. This is the orientation of the bolt. And then for the hex nut, rotate it about the y-axis, and this will be the orientation of the hex nut. Move on to the screw, and then you have to rotate the screw about the x-axis this time. This will be the orientation. Click to release, and then finally the lock nut, rotate about the x-axis, and this will be the orientation. We are going to add mates with the temporary axis. So come to this eye icon, and then you want to enable the temporary axis. So these are the axes of the holes and everything that we have, the shafts as well. Now come to mate, and then we add the first mate, which will be between the axis of this hole inside the swivel and the holes inside the arms of the base. So under standard mates, click on this axis of the hole here, and then this axis of the arm. Okay. We want to center the swivel between these two arms. So you come to advanced mates, we use a width mate, and then we have two faces here and two faces here. So the first set of faces will be the faces of the arms, and then the second set will be the faces on the swivel. Okay. Now when you click on the swivel here and then move it, you can see there is 1 degree of freedom, so we want to make it stationary. So again, standard meets parallel this face and this face, make them parallel. Okay, now when you click on the swivel and try and move it, it doesn't move again. So the swivel is okay. Next, we insert the bolt. So still under standard meets the axis of the shaft here, and then this axis of the hole. Okay, now click on it and pull it backwards. Now click on this face and then mate it with this face. Okay, now when you click on the bolt and move it like this, there is another degree of freedom. So again, parallel this face and this face. So the bolt is done with, and then we insert the hex nut. So with the hex nut, you are going to use a mechanical mate. So come to this mechanical mate, screw motion. Since this is a bolt and nut, use the distance per revolution, and then select the axis of this nut first, and then the axis of this bolt. You have to select the nut first before you select the bolt, so that the motion will be on the nut and not on the bolt. The distance per revolution, let's keep it at 5. Okay, now when you click on this nut and then move it, rotates, as you can see, in a clockwise or anti-clockwise direction. Okay, and rotate it in the right direction. We can see the nut moves towards the bolt. We bring it up, and we want to set the limit in which the nut will move. So again, come to mate, and we want the limit to be between the part of the shaft that is visible. So we go to the dimension on the bolt, and the length of the thread here is 20 millimeters. So the distance from this face of the arm on the base to this final face of the bolt will be 20 millimeters. So come to advanced mate, and then we use the limit distance between this face on the arm and the limit distance. We need the shortest or the minimum distance, and then the maximum distance. So the minimum distance between them should be 0, which will mean that they will touch, and then the maximum distance between them should be 20 millimeters, which is the full length here of the screw with some offsets. So okay, and now let's try and move the nuts. Okay, so this is it. Then we move on to the screw and the lock nut. So again, come to mate. First, you're going to place the lock nut on top of this. So first, align this center axis of the lock nut and then the center axis of this swivel. Okay. this is the lock nut. So click on it and pull it up like this, and then place this face and this face together. Okay. Now we don't want any rotation, so just lock the lock nut and then the swivel. Okay. Finally, we are going to place the screw also. So just like we added a screw motion here, we add a screw motion to the screw as well. So you come to mechanical meets, screw motion, distance per revolution, and then this axis of the screw, and then this axis of the swivel. So this direction will be the direction to move downwards. So okay, click on this screw and pull it up. Just come here, pull it to the top like this. Okay, so since we've added a screw motion, you have to move it in order to get it up. So okay. Just like we did for the nuts, we also add a limit distance. So there will be a distance between this face and this face. So meet, advanced meets, and then we use a limit distance between this face and this face. You have to calculate the minimum and the maximum value. So we go to the dimension on the screw. We want this tip of the thread here to be lying on the lock nut. We have to calculate the distance from this tip to the end here. That will be 56 minus 32. .24 millimeters. So the minimum distance between them should be 24, and the maximum distance will be the full length of the screw, which is 56. Okay. You see fully defined assembly. So click on this edge and move the screw upwards. It doesn't go up again, and it doesn't come inside again, so it will move just within this distance. Disable the temporary axis, and this is the final assembly, and this is the end of the second part of this tutorial. So thanks for watching. In the next part of this tutorial, which will come right after this video, we'll create the exploded view. So I'll see you in the next tutorial.